Hey guys, this is Devanshu Padhya. I'll be covering all the questions from the Urge Google 30 Days Challenge playlist. And this question consists of 100 to 90 questions from top 6 companies like Google, Microsoft, Goldman Sachs, Amazon, and different companies. So I'll be covering all these questions. I'll be talking about the most brute force, optimal, and the most optimized solution so that I can provide the overall thinking. And I will also share my approach and intuition that will help you uh, to think the question in every aspect. So think about the question in every aspect. So I will be starting with Microsoft because I think Microsoft does have more tricky questions than Goldman Sachs. I haven't completed it yet. There are some questions which I have completed and yet to be marked as done, but I haven't completed it as. And the 6 to 5 questions are still left, but I will be covering those also. So I will start with this random. So I will start with this random point in non-overlapping rectangles. Why I'm starting from here? Because some certain questions required a bit of thinking. I think certain questions required a better thinking, or you can say it requires more of a dive into the intuition game. So what I will do, I will start from I will pick 4 to 5 questions and put them in one video. Those questions are really easy and that doesn't require much of a thinking. But if some question require much of a thing like flip matrix, the maximum of 2 arrays, or there was this maximum some BST, these questions required a bit of uh, more intuitions more intuition. So I will cover them in a separate video, and in those video I will talking about the brute, optimal, and the most optimized way of solving all these questions. So stick around and let's start with it. So I will be covering only this video because I'm starting this playlist and I want to start on a good note, like you can digest the questions also, and also it will be really helpful. I can say it is a very good way of starting this whole playlist because this question is not that difficult, but it has some tricky points in it. So I'll be starting this question. Yeah, let's begin. I'm hiding this because let's say I don't want to spoil this question for you. I want you to think about it, and you can pause the video to think about it. So here are given. Uh, I will be talking in both Hindi and English so that majority of the audience can understand it. So you are given an array of non-overlapping axis-aligned rectangles, where rect of I means a of I, comma b of I, comma x of I, comma y of I indicates ai, comma bi of the bottom left corner and of the ith rectangle, and xi, comma y on the top right corner of the ith rectangle. Basically, this and this point. So there is an array which consists of non-overlapping rectangles. Those rectangles are not overlapping. They are not overlapping, but also they are axis aligned. That means they are not rotated or shifted. They are axis aligned. Okay. So you can say that if the length of the rectangle is following the y-axis, the width of the rectangle will definitely follow the x-axis. That's I can say. The rectangle is not like this. They are not rotated. Okay. The rectangle is not like this about the x-axis. Okay, so we can say that is called axis aligned. Okay, then design an algorithm to pick a random integer point inside the space covered by one of the given rectangles. A point on the perimeter of a rectangle is included in the space covered by the rectangle. They are saying basically we have to design a random algorithm using the random function, obviously. Okay, there is one thing. LeetCode hasn't mentioned that it has to be uniform. Okay, they haven't mentioned that. It has to be uniform. I think this is why a lot of people fail in executing this problem, because I will talk about it more. But have to find. You can see in so we have to find we have to randomly print a point which is inside the space covered by this rectangle. Space in the coordinates, in the whole coordinate universe, I can say these rectangles are there, and you have to pick out those points which are inside one of these rectangles. Any integer point inside the space covered by one of the given rectangles should be equally likely to be returned. Okay. Note that an integer point is the point that has integer coordinates. Obviously, we can't go for decimal point because there will be infinite points. Implement the solution class. Solution int. This solution class basically create the rectangle. This will give us the rectangles, all the rectangles. Not create all. It will give us all the rectangles. And an int pick will with the solution which will return the x and y values. You can see there is no mention of uniformly returning. What does I mean by uniform returning? Let's say there are n rectangles. Okay. No. Not talk. Let's break it down with. Let's say there are 2 rectangles. This will be more visually appealing and this will be easier to understand. The first one is A1 and the second one is A2. This rectangle is much more bigger than this one, hence it will have more points. And this one will have less points. Now you will be saying, yeah, obviously it is smaller. But the question never said that we have to return a point which is uniformly in both of this rectangles. That means, let's say A1 and A2, let's say A1 is here and A2 is here. They are covering certain areas, right? The probability of picking between these 2 rectangles is 1/2. Obviously, what I want to say that if I'm going to uniformly bring any of this, so what there is no mention of uniformity. So what a normal person will do, he will think, okay, I can pick any of randomly. I will pick any of these rectangles, randomly picking between A1 and A2. But hey, what is the probability of picking randomly A1 and A2? That is 1/2, right? Okay, I'm picking 1/2. That's cool. But as I said, A1 consists of n particles, or I can say L coordinates, but I'm talking, let's consider each coordinate as particle, n particle, and A2 consists of m particles. And we know n is greater than m because area of A1 is greater than area of A2. So what will be the probability of picking one particle from n particles? One particle from n particle. It would be obviously 1/n. Similarly, for 1 from m equal 1/m, right? Now, if I'm doing if I'm randomly selecting any of this rectangle, then probability of picking one particle from n equals to 1/2 into 1/n, isn't it? Like it would be 1/2 into 1/n, right? Makes sense. Yeah. Like first off, we have the probability of picking A1 as 1 by 2, and the probability of picking one element from n elements is 1 by n. Total probability will be 1 by 2 into 1 by n. Similarly for A2, it will be 1 by 2 into 1 by m. So if a normal person will try to create this solution, and by normal means a person like me, obviously. So 1 by 2 into 1 by n, this is the mistake I genuinely did. That's why I'm saying 1 by 2 into 1 by n, and then 1 by 2 into 1 by m. This is the solution. LeetCode wants this, right? Because they never mentioned it. They never mentioned that I have to pick it uniformly. And what does I mean by uniformly? Uniformly means the probability of picking one element from n should be 1 by k, which should be equal from 1 out of m. How can we do that? This is what uniformly means. And when I submitted this solution, by making sure that I am picking at a constant probability, each elements are at constant probability, my solution got AC. What I'm saying about is, let's the probability depends on two factors: size of rectangle. If the size are equal, then it's okay, because n will be equal to m, and then 1 by 2 into 1 by n equals to 1 by 2 into 1 by m. That is okay. That doesn't, if the size of the rectangles are okay, that's why it will give AC on certain cases. But if the rectangles are of different sizes, then we have to consider this solution. And it is not mentioned in the LeetCode question, and I don't know why they don't mention it, but it is a pretty common, maybe this is the reason this question is counted as a medium question, unless it would be counted as a easy question. Okay, the size of rectangles. The size of rectangles does matter. The probability depends on the size of rectangle, and also which one I'm choosing. What I'm doing is that, let's say there are k rectangles, and I'm randomly choosing one of them. That would give me a 1 by k probability, and it will multiply to the 1 by n, that is the number of elements. But instead of choosing randomly that 1 by k, why don't I, let's say, you will understand this with better you will understand this better with examples. Let's say A1 has an area of 70, and A2 has an area of 30. Why don't I make it that the bigger area gets selected first, get selected more? Like the probability of selecting this A1 square is more, A1 rectangle is more compared to this A2. Instead of randomly picking from the array of rectangles 1 by k, like k rectangles, and randomly picking 1 by k. What I'm saying is, instead of randomly picking, I am providing a different probability for different rectangle. That is, I'm giving a different probability to this rectangle and different to this one, depending on their sizes. This will come as a trade-off. Okay, this will make sure that when what I'm doing, the probability of choosing this rectangle will become 70 by 100, and the probability of choosing this rectangle will become 30 by 100. Okay, that makes sense, right? That makes sense. That is 7:3, they are in the ratio. Okay, so this will and the number of so what will that, there are total 100 particles, let's say 70 will be from this one and 30 will be from this one, obviously their area. This is why I'm saying that examples helps more. Then by 1 by 70, there are 70 elements, 1 by 70, and breaking from 1 by 30 element, that would be 1 by 30. This seems pretty easy to deduce, right? Like, whoa, okay. But that made the probability of picking any element equal constant, and it can be done using. So what the conclusion? Create an algorithm. The better question should be create an algorithm so that we pick squares depending on their sizes, and then return any coordinate. This seems like pretty logical now. Like, instead of going from 1 by 2 into n or 1 by 2 into m, we are going 1 by k, because we are not choosing 1 by 2. Let's say here it is 2 because we have 2 elements. It can be 1 by n, or let's say different elements, different name, not n. It can be alpha. Okay, 1 by alpha, not 2 alpha. Okay. So if it is sorted, I will suggest you to do it on pen and paper and try out some examples. That will really help, because it helped me. So we did that. Okay. Now the solution should give AC. The optimal approach is what I mentioned, not the one where we were picking randomly from the array of rectangles. So that was it, because the coding part is much easier. So what we will do in there is one more thing. Okay, so how we will the algorithm is easy, but it may be difficult for some people, because they may be struggling with deducing the probability factor. So it may be difficult for them, but when you will see the algorithm, I think most of your problems will cease to exist. Okay, the algorithm. So instead of picking it like this, each rectangle is like, अरे भाई मैं तो तेरे से बड़ा हूँ, मेरे को पहले जाने दे, मैं तेरे से बड़ा हूँ, मेरे को पहले जाने दे. So why don't we create a slab of rectangles? Slab of rectangles. हमने slab of rectangles बना दिया. Let's say the first rectangle of 10 size, the second rectangle of 20 size, total size 30. Third rectangle again of 5 size. Okay. Fourth rectangle 30. Fifth rectangle 30 again, and then again of 10 size. Okay. Why will this slab will help us? Let's say we will create a prefix sum of this whole vector. So the slab will be like 10. This sign is like I'm merging both of them. The slab will become 30 here. Merging 35. Merging. Why I'm not doing it in a typical prefix sum way? Because it will be much easier to visualize in this way. Now, because it's 35, and that will be, wait, sorry, 65, another 30, 95, another 10, 105. So our function, our algorithm should give out the probability in this fashion. Like the biggest rectangle should have more probability to go out. Biggest rectangle should have more probability to go out. Here the biggest rectangle is of 30 size and there are two of them. Okay, the probability should be 30 out of the sum of the rectangle. 30 out of the sum of the rectangle. Okay, the probability should be like this. Okay, that does make sense. All right. So how can we do that? We are what 30 out of the sum of all rectangles. So this way, what we can do is, why don't we just look into our slab? Hey, let's say the sum is 105. Let's say the sum is 105. Hey, let's randomly pick a number. Let's randomly random function is picking a number, and let's say it is 13. Which number is just greater than 13 in this array? Just greater than 13. It started with 10, then increased 30. This number is just greater than 13, right? Okay, this number is just greater than 30. So if this number is just greater than 13, that does mean the point which I am looking for lies in this area, right? The point which I am looking for lies in this area. What does I mean? Let's say the random number is 61. The number just greater than 61 is 65, which means the number I'm looking for lies here, somewhere around here. Okay. The number I'm looking for lies here, which means in this block. If I will say, please give me a number, so I will create this in a better fashion so that it's not confusing. 10, 30, 35, 65, 95, and 105. So let's say I will say 61. This means it lies in here, because from 35 to 65 there is one block. This block has 30 elements in it. So if you think about it, this makes a lot of sense. Let's say the number comes out to be 91. It will lie here between 65 to 91. So which block is in the position of 65 to 91? The 30 size block again, and it covers the maximum range, right? Maximum range. This definitely means like if it's covering the maximum range, this means the probability of getting this number, the number from 65 to 95, is higher, right? Because it has 30 elements in it. 30, because hence the probability will be increased. The probability from getting 65 to 95 is definitely more as compared to getting from 10 to 30, because there are 20 elements. Now we can see our algorithm does make sense. Oh, we can just create a slab of rectangle areas and just pick any random value, and depending on that random value we will create, because this is a prefix array, and depending on this random value we can find the value just greater than the random number in log n, because it is a prefix array and we can use binary search on it. Okay, that makes so much sense now. Like this is the this pen. this is the array, and it has areas in it. This area, like this area, then this area. The probability of finding a number in this area is hell more than this and this. So if I create a random function, let's say r equals to rand mod sum of total area, the probability of getting in this part is more than this. Oh, sorry, is more, right? That what I wanted, to make algorithm such a manner that the bigger area get picked out most, that it get picked out most of the time, and it is picked out more than this and this and this. Hence we can just, now the algorithm becomes like, create a prefix array of rectangles area, and do a binary search on each random number which you just picked. The just greater value can be calculated with upper bound in log n time, and you will choose that rectangle to print the sum, print the coordinates. This is a question. This question was not giving AC to a lot of people, because what we were doing, we were picking out areas in 1 by k, that k is the number of rectangles. This is wrong. We have to pick area based on their sizes. We have to pick rectangle based on their sizes, based on their area. That's why what we did is we created slab of rectangles which is consisting of all the total sum of the areas in a manner that it is in a prefix sum. So a rectangle which has bigger dimensions will be picked more as compared to the rectangle which is which has lesser dimension than it. So the typical solution is like, create a prefix sum array and then do a rand function on it, and if once we get the rectangle, it is pretty easy. Like we can create a rand from this value of this value of x to this value of x, and this value of y to this value of y. We can just create a random, we can get all the coordinates in this part and all the coordinates in this part, and we can get all the coordinates inside this area. That would be the easier part. Again, what I'm basically doing is creating a temporary array, temp array. What it does, it just stores sum of areas. It's like prefix sum. Let's say the areas of each rectangle is 5, 4, 6, 8. So the first area came out to be 5. The sum was 0. So sum becomes 5. Then the next area comes out to be 4. The sum becomes 9. The next area comes out to be 6. The sum becomes 15. And the next area comes out to be 8. The sum becomes 23. And we'll be keep pushing these areas inside the array. So 5, 9, 15, 23. Now our next work is creating a random variable on this 23. So rand of mod 23 will give certain values. Let's say it gave me 14. So it means that it lies in here. The just greater than value, let's say it gave me 14, which means it lies in this, the third rectangle, and its area is 15. So what I will do, I will take that rectangle, that is, I will take the index. So what in the index can be found using upper bound. So idx equals to upper bound from in the whole array area dot begin. You know what way we do this, right? Area dot end and finding that rand variable upper bound minus area dot begin. Why we do area minus? Because we need to, because the upper bound will point, it will provide the pointer to that value, but we need a integer index, so that's why we subtract it from dot begin, because these are iterator terms, and that why and I need an integer term, integer variable, integer value, sorry, and that's why I do it with idx, int idx equals to. Now I got the rectangle, so in the rectangle array I have idx, I got it, and now I will print out x and y. This question is not that difficult. The main question is like how are you going to uniformly pick out the rectangle? Picking out the rectangle is the main gist of this question, and that's it. Now I will code it. So okay, let's code it. So what were we doing? We created a temporary area vector. Just a second. My keyboard had some issues. Okay, yeah. So what were we doing? We will create a temporary area vector. Let's give it a name as area. And we are also creating a vector of rectangle, vector for rectangle, because we can't access this rectangle everywhere, right? We need to store it somewhere. So what we will do, we'll create a vector of vector int rectangles. Okay. Now rectangles, the name is too big. I don't prefer such name. That's why I'm only giving it rect. Rect will be a perfect name. Okay. So rect equals to rects. We're just copying the rectangle, and for each rectangle, for auto IT, rect, what I'm doing is just, oh, we also need the total area sum, right? So total, let's say int sum equals 0. So we'll we'll find the area. So let's say int ar equals. Now finding the area is simple. Okay, finding the area is simple. We know in description ai is the first coordinates and xi is the second coordinate. Okay, so we'll do abs of it of 2 minus it of 0, because 2 is our second x coordinate, plus 1 into abs of it of 3 minus it of 1 plus 1. This will give us the area. This will give us the area. We will save this area in our area vector, area dot push back ar. We will keep pushing those areas, and it will create the prefix sum array also. Okay, we did that. Now let's come to the pick section. the pick section, in the pick section, what we were doing is taking the last element, that says int temp equals to area dot back, and creating a random variable rnd, finding the random variable equals to rand of modulo temp. We were also doing finding the id index, so idx equals to upper bound area dot begin comma area dot end minus area. Oh, we also need to put our rnd because that is our variable, right? Minus area dot begin. This will give us the index of that particular rectangle which has the area just greater than our random variable. Now if we get our so if we got the index, we just need to create a vector for that particular rectangle. Vector temp r equals to, or let's say we haven't used r anywhere, right? So r equals to rect of idx. That's why I created a temporary rectangle variable that I can access it in both functions. Okay, so vector int r equals to rect of idx. That was it. Okay, x and y variable. So ntx will be similarly like this one. I have to create a random in this total sum, so I'll just copy it. So it's like rand of in this particular distance plus r of 0. Difficult task. Just return x comma y. Let's run it, and sorry, how can I do this? It would be r, obviously. This should give right answer. Okay, let's submit it, and it will get submitted. The problem is not that hard. I will say it is not that hard. The just okay, the mistake was pretty evident. I didn't summed it up. And I need to push sum, right, because AR is the current area, not the total. And this should work definitely. You can see why it failed, right? Because I'm pushing the current area, and that will create problem because the probability is now 1 by n, total number of rectangles. Also the upper bound must be working wrong because it was not in sorted order, but now this should definitely get submitted. The question itself is not hard. The approach is really great. Okay, the approach is this approach is really great. But if you do the 1 by n term, it will stuck. It will stuck, and that may be the reason why you're watching this video, because it has stuck. Or maybe you wanted to know the approach behind it. But yeah, it will get stuck if you are using that the ideal solution. Like, let's say we are picking any rectangle randomly, that will provide errors. I don't know why LeetCode didn't add the term, or they could have used examples to show that you have to pick uniform answers. It's okay. So we'll see you in the next one. The next question would be overlap circles and rectangle. Okay, what I will do, because this question is easy, I will pick this one into who is the winner. I don't remember. Yeah, this question is very intuitive. I will pick this one and this one, and image smoother is, I don't think I require a video on it, because it's a pretty easy question. So I will pick overlap circle and rectangle along with minimum move to equal array elements in one video, and I'll be covering them next. Then we will go for envelope and dolls, and then we will start, and we will then first we will complete Microsoft, then we'll go for bulls and cows, and that in that order, and then we will go for Goldman Sachs. Thank you for watching.